13.1 Trigonometric Identities. So in this lesson, we're going to talk about how to use trig identities to solve problems and simplify expressions. So here's a basic trig identity you're supposed to know. So some of these we have already. Right? We should all know that tan equals sine over cosine. It's a big one. And if tan equals sine over cosine, cotan is just reciprocal, so cosine over sine. All this stuff, cosine, theta cannot equal 0. It's like, who cares? So that's a big one, tan equals sine over cosine, and then its reciprocal function, cotan equals cosine over sine. And we're going to use these a lot. Now the other ones, other things we should know already, right? Sine is 1 over cosecant, cosine is 1 over secant, tan is 1 over cotan, cosecant is 1 over sine, secant is 1 over cosine, cotan is 1 over tan. By the way, I want to add on to this, right? We usually think about it this way. Like, oh, sine is 1 over cosecant. But you can also think about it that way. If I give something like 2 over cosecant, that's the same thing as saying, hey, you can move the cosecant to the top and it makes it sine. So it'll be 2 sine. So these both go both directions. If you have a sine on the bottom, it makes a cosecant on top. And if you have a cosecant on top, it's a sine on the bottom. So all those are all the review ones. Now let's talk about the new ones. First one's Pythagorean trig identities. So here's the most important one. Cosine squared plus sine squared equals 1. And that comes just from the unit circle. Right? If we do a little unit circle here, it's a unit circle, so that's 1. This is your x value. This is your y value. Remember what I said before? X is cosine. Y is sine. Sine. So cosine squared, x squared plus y squared, right? Pythagorean theorem, equals 1. So cosine squared plus sine squared equals 1. So that's where it comes from. So this is it's probably the most important one of all mathematics of trig. Cosine squared plus sine squared equals 1. We have to know that. And on top of that, you could play with this. Let's say I want to know what sine is by itself. Subtract cosine from both sides. I get sine squared theta equals 1 minus cosine squared. Likewise, let's say you want to get cosine by itself. Subtract sine from both sides. Cosine squared equals 1 minus sine squared. So these are like just as important. So we're going to use all of these a lot. Cosine squared plus sine squared equals 1, which is the most important formula in trig. And then if you want to get sine by itself, just subtract cosine from both sides. You get sine squared equals 1 minus cosine. If you want to get cosine by itself, subtract sine. Cosine squared equals 1 minus sine. So those are all formulas you have to know, right? So again, sine squared equals 1 minus cosine squared. And cosine squared, because it looked like trash earlier, equals 1 minus sine squared. All super important. Now those are the big ones. Here, these are also important, but not as important. We don't use these as much, but they are helpful. And that one is tan squared plus 1 equals secant squared. Cotan squared plus 1 equals cosecant squared. Now this one looks like a lot. But if you look at it, it's not that bad. It's just a tan squared plus 1 equals secant. Over here, right, it's the same thing. It's a tan squared, so it's always a tan squared plus 1. But since it's cotan, it goes with cosecant. So the cos go together. And then it's tan squared plus 1. Like, that's how I remember it. Like, I always know it's the cos go together. So if I have cotan squared plus 1, it equals cosecant. Tan squared plus 1 equals secant. Another way you can do that is to go back to our basic formula. Cosine squared plus sine squared equals 1. Divide everything by cosine. Squared, I should say. And what happens is this. This is just 1. Sine over cosine is tangent squared. 1 over cosine, secant squared. So that's where they get these from. If you want to divide everything by sine, you're going to get this one here. So the real trick is, know cosine squared plus sine squared equals 1. That's all you need. If you know that one, then you can find these two, then you can divide them and get these two. That's the key. Now these right here, you can focus more next year. We don't really do much of these in algebra 2. These are the cofunction identities, and then these are the negative identities. So again, we're going to do more next year. For this year, we're going to focus really on how to switch things and how to use the Pythagorean identities. So first step, Actually, more of a review problem. We've done this before. So we want to find cosine theta given sine theta equals 4/5, and we're in quadrant 1. That's what that means, quadrant 1. So what I taught you how to do is draw a triangle in quadrant 1. Sine is 4/5, so opposite's 4, hypotenuse is 5, right? So good TOA. We can find the missing side by doing a squared, b squared, c squared. So we should know this triangle by now, it's a 3. And if I want cosine, we do so good TOA, which is a over h, 3/5. And we're in quadrant 1. All students take calculus, so it's positive. That's why I taught you to do it. That's review. You can do it that way still. You can also do it using the trig identity, the most famous one, of course. Sine squared plus cosine squared equals 1. Sine is 4/5 squared. We want to know what cosine is. So this one just involves more mathematics. So I get 4 squared, 5 squared is 16 over 25. Plus cosine squared equals 1. Subtract this from both sides. 1 minus that's common denominator, 25 over 25. So I get 9 over 25. And then square root it. Square root of 9 is 3. Square root of 25 is 5. And again, quadrant 1, so positive. So that's the way to do it using the trig identities. So if you want to solve it using the trig identities, you just do sine squared plus cosine squared equals 1, plug it in and solve. I think the easier way to do it is just make a triangle. Make a triangle, figure out the sides, and there you go. Same thing here, right? Cosine's 2/3. So just draw a little triangle. Cosine is adjacent over hypotenuse. Forgot the missing side, a squared, b squared, c squared. I guess you gotta work on this one. 2 squared plus b squared equals 3 squared. 4 plus b squared equals 9. B squared equals 5. B equals rad 5. So like that. And then I gotta find cosecant. Remember that's the opposite of sine? Sine's so. So cosecant is ho. So hypotenuse over opposite. And again, quadrant 1, so everything's positive. So that's when that works. Let's do one where it's not in quadrant 1. Oh, these are the same. Let's do this one. So the last one of these we'll do. So same idea, right? If sine equals that, cosine equals that. So I like to draw a triangle. You can also do it using a squared plus sine squared plus cosine squared equals 1. So cosine, so 1 and 3. And actually I drew this in the wrong quadrant. Look what it says. 270 and 360. So 0, 180, 270, 360. So that should be down here. It's a terrible triangle. So TOA 1 and 3. Find the missing side. 3 squared minus 1 squared is going to be 8. So radical 8. Now here's the thing. 2 ways to figure out if it's positive or negative. One way is you're going down, so it should be negative. That's always positive. Other way is just use a SOHCAHTOA. So we're doing sine. I meant to use all students take calculus. That's what I meant to say. Opposite of hypotenuse. So let's say you put rad 8 over 3. I'm not sure if it's positive or negative. Just do all students take calculus. Only cosine is positive in quadrant 4. We're doing sine, so negative. Right? Either way works. We'll skip down until we've done that a lot. Now let's get to the real new thing of this lesson. That's simplifying expressions. So we're going to want to simplify things. So a couple hints. Hint 1 is honestly just know your stuff. Know your properties. Know the identities. This isn't even possible if you don't know your identities. If you don't know if sine squared plus cosine equals 1, or if cosine equals 1 over secant, you're not going to be able to do any of this. So you have to know your identities. So like taking a bio class, like you got to know the definitions, otherwise it's pointless. And then 2, if you're not sure how to do something, because we're going to simplify stuff. So I'll say use identities when use identities. We'll talk about that in a second. But 3rd, if you're not sure how to do stuff, just change everything to sine and cosine. That's like a last resort. Change everything to sine and cosine. So those are the ones we're best at. We're really good at sine and cosine. All the rest we're like about. But sine and cosine we're good at. So as a last resort, if we don't know what to do, just change everything to sine and cosine, work from there. So look at this first one. Let's talk about what they want us to do. So they have sine theta, cosecant theta over cotan theta. So already they want me to simplify it. So you want to go, okay, let's look at cosecant. So cosecant is is 1 over sine. So this is the same thing as saying sine theta times 1 over sine over cotan theta. Well, sine and 1 over sine cancel out. You just get 1. And by the way, I could know that from here. Sine and cosecant are reciprocals of each other, so they just cancel out, and you get 1. But that's why. So you just done that there. Now you have 1 over cotan. If you remember 1 over cotan, what's the reciprocal of cotan? Tan. And that's it. That's all they want you to do, right? They want you to use the identities you know. So I'm like, oh, I know sine. Cosecant is opposite of sine. So I wrote 1 over sine. These cancel out. I get 1 over cotan. What's opposite of cotan? Tan. That's kind of the idea. That's an easy one, though. Let's do a harder one. 24, let me skip for a second. Let me do this one first. So I got secant over sine. And then right here I got 1 minus cosine squared. So when I say use your identity, this is what I mean. Like this right here is an identity. 1 minus cosine squared. Let's look up. Where does I see that at? Right here. 1 minus cosine squared is sine squared, right? It comes from the basic formula right here where you just solve for cosine or sine. So this is the same thing as just saying sine squared. So why we gotta know our identities. It makes it a lot easier if we know our identities. If you look what happens next, we have sine squared, which is just a number, so it's over 1. Sine squared and sine cancel out, and I just get secant sine. Like I'm done. Not really though. You could change this. Secant is the same thing as 1 over cosine. Sine over cosine. Remember sine over cosine equals tan. Right, so it's just using identities to break your way out. That 1 minus cosine equals sine squared. So now you have sine squared times secant over sine. The sines cancel. Then you have secant sine, which is 1 over cosine times sine. Sine over cosine is tan. I'll go back to the one in a second, I promise. That one's a little tougher. So look at this one. I got 10 times cosine theta. So I really can't do much here. So remember my last rule is change everything to sine and cosine. So we're going to change sine, tan to sine over cosine. So if we're not sure what to do, change everything to sine and cosine. And just like the one we just did, if you notice, the cosines are going to cancel out. This is cosine over 1. This cancels with this. And I just get sine theta, cosine theta. That's really all I could do. Now we're getting to a tough one. Cosecant squared minus cotan squared. Now there's a lot of ways we could go with this. Now it all kind of depends how good you know your rules. So if you know these rules right here, like the extended ones, we could rewrite this. Like if you know the extended rules, cosecant is the same thing as saying 1 plus cotan. And then you have 1 plus cotan minus cotan squared. So these cancel, you just get 1. That's one way to do this. Now let's say if you didn't know those rules very well. Well, we could do my third rule. My third hint. Change everything to sine and cosine. Cosecant is 1 over cosine squared. Cotan, tan is sine over cosine, so cotan is cosine over sine. So again, this is the shortcut way. This is a long way. So I have this. And my next step is I need a common denominator. Oh, I messed this up. Cosecant is 1 over sine squared. Oh, that's embarrassing. But luckily it makes the problem a lot easier. So this is 1 over sine squared, sorry. Now if you notice, these match the same denominator. So you can just add them. And I get 1 minus cosine squared over sine squared. 1 minus cosine squared, sine squared. and these cancel, and you get 1, just like we got the first time. So again, shortcut, if you know these rules, it makes life a little easier. If not, you can still do it. Change everything to sine and cosine, common denominator, so you can combine them, and then 1 minus cosine squared is sine squared, sine over sine is 1. Let's go back up here. This one I didn't want to do. So I'm going to do a little shortcut. I'm going to flip this up like I talked about before. There's a little shortcut doing that. So I'm going to flip that up. So I'm going to have this. Tan squared theta cosecant squared theta minus 1. All times, if that's on the bottom, if you flip it, it makes it the opposite. So in this case, cosine squared. Now let's see if I can do anything here. So tan is sine over cosine. Since it's squared, they're both squared. Cosecant is 1 over sine. Should put thetas on everything, honestly. Minus 1. Right, so this tan is sine over cosine. Cosecant is 1 over sine. Look what happens. Boom. 1 over cosine squared minus 1 times cosine squared. Now what could I do? Well, we can distribute. Do a little algebra. This goes there. This goes there. Now cosine times 1 over cosine, this gives me 1. Cosine times negative 1 is negative cosine. And you get that far. And like, could you go a little bit further? Remember what 1 minus cosine squared equals? We did like a second ago. We did it right here. It's sine squared. And that's that one, right? That one's a tough one. So first thing I did was I did the trick where if it's on the bottom, you can move it to the top. So secant squared on the bottom is the opposite on top, cosine squared. Then I worked on the inside. Tan is sine over cosine. Cosecant is 1 over sine. These things canceled out. I had 1 over cosine. Then I distributed it, and I got this, which gave me that. Right? Tough stuff. Let's go over a couple more, and then we are done for today, for this lesson. We'll do some more in the next lesson also, by the way. So look at this one. Let's try that same trick. I have tan on the bottom. Unlike fractions, move it to the top. Remember, it becomes opposite. Cotan. So now I have this. Let me rewrite it. Cosine theta, cosecant theta, it's a big C, cotan theta. All being multiplied. What do I do here is my last hint. If you're not sure what you're doing, if you're not sure what to do next, just change everything to sine and cosine. Right? I'm going to leave cosine. You always leave cosine and sine. Those are golden. Cosecant you want to change. 1 over sine. You have to know your identities, man. Again, cannot do this without the identities. Cotan, remember tan is sine over cosine. Cotan is opposite. It's cosine over sine. That's how I do it. I know what tan is. I just flip it for cotan. So you have this. And look what happens. I get cosine. Remember, you multiply across, so I get cosine squared over sine squared, which is cotan squared. So that's that one. I thought it was going to be more interesting, but that's what that one looks like. Listen, look at the next one. Rewrite in terms of sine. So let's change cotan to cosine over sine, and tan to sine over cosine. So I get that. Now here's the thing. I want it in terms of sine. A lot of people that try to cancel these out like that. You cannot do it. It's a minus sign there, not a subtraction sign. Sorry, it's a subtraction sign, not a multiplication sign. Right, so these do not cancel that way. What we could do, though, is get common denominator. Like, let's say I give you 1 over 2 minus 3 over 4, 5. Right, the way you add these, you don't just cancel things out. You common denominator multiplies by 5 over 5, multiplies by 2 over 2. Same thing here. This has a sign on the bottom. It needs a cosine. So multiply by cosine, cosine. Multiply this side by sine, sine. So I'm going to get cosine to the 4th over sine squared cosine squared minus sine to the 4th over cosine squared sine squared. So the other thing, now we can combine them. I get cosine to the 4th minus sine to the 4th all over cosine squared sine squared. You're like, that's disgusting. It is, but we can go a little further. This factors. Come on, honors. difference two squares, right? This is x to the fourth essentially minus a to the fourth, which is x squared minus a squared, x squared plus a squared. Difference two squares. Same thing here. So I'm going to get cosine squared minus sine squared, and cosine squared plus sine squared, all over cosine squared sine squared. Okay, so what happens next is this. Cosine squared plus sine squared, that's just 1. Right? It's the most famous rule of trig. Cosine squared plus sine squared is 1. You have to know that one. If you don't know anything, learn that one. So I'm left with cosine squared minus sine squared over cosine squared sine squared, which is pretty much as far as I could go. Remember, these do not cancel. There's a minus there, so that's stuck. So this is pretty much it. If I want to do anything, one thing I gotta do, since I want it in terms of sine, I'm gonna change this cosine squared to 1 minus sine squared. I'm gonna change this cosine squared to 1 minus sine squared. Only because I want everything in terms of sine. So I'm gonna get 1 minus sine squared minus sine squared over 1 minus sine squared times sine squared. Right, again, only because I want everything in terms of sine, I switch those. And then now I just get 1 minus 2 sine squared over distribute sine squared minus sine cubed to the fourth. That's pretty much it. That's as far as it could go. Right, that was a little ugly, but the general idea was the same. Right, I'm not sure what to do, so change everything to sine and cosine. So cosine over sine over cosine. I need to multiply these, so common denominator, cosine, cosine, sine, sine. Got me this monstrosity, so I combined it, and I got this. I could factor that to difference two squares, so cosine squared minus sine squared, and cosine squared plus sine squared. That is 1. Cosine squared plus sine squared is always 1, so you have this. And normally I would have left it, but it said put everything in terms of sine, so I changed all the cosine squares to 1 minus sine squares. And that's it.